So I'm going to start off with like a little introduction. So can you all introduce yourself with like 30 seconds about who you are and what VM you represent?
Hi, everyone. I'm Hai Chen from Scroll. So Scroll is building the zk EVM and then zk ROP to scale the Ethereum. So like as we said, like we already building the zk EVM, so we're on the EVM team, trying to be very EVM compatible and equivalent. That all of the smart contracts that can be deployed on the Ethereum should be able to deploy on the Scroll.
Hey, I'm Neil, and we're building Eclipse. So we support multiple bytecodes like EVM and SVM, SVM meaning the Solana VM, but ultimately under the hood, it's always using the Solana C-level virtual machine.
Hey there, my name is Harry. I am one of the co-founders and the CTO at Off-Chain Labs building Arbitrum. We are currently, our bread and butter and the way we've been for the past year and a half has been kind of EVM equivalent, although we are now very excited to be working on a new project called Stylus, which is going to allow for us to also execute WASM contracts interoperable with EVM contracts and trying to kind of push this idea of EVM plus, where we keep the EVM, but we build on more powerful tools around it.
I'm Ben, I'm from Starkware. I'm representing Cairo and the Cairo VM, a provable programming language. And since we're all live in a simulation, I'm representing the reality VM.
Yeah, so to kind of start off, the title of this panel is pretty loaded because it implies that there's an EVM and then there's everything else. And so I'm actually going to ask Harry to start off with this because with your EVM plus, you know, do you agree with this assessment and what would you title this panel?
No, it's a good question, and it's funny. I had been thinking about beforehand how I was going to say, and you kind of stole my thunder. EVM versus alternate VMs, why choose? You know, it's interesting, and kind of the thing with EVM equivalence, and the EVM is kind of interesting in that it has like a huge amount of adoption, but it's certainly, I would say, it's not many people's favorite architecture. It is kind of the common thing that sort of a huge amount is built on. And it makes a lot of assumptions, and smart contract developers use it. A lot of times they might not be like blockchain experts, and so kind of maintaining the idea that you can kind of use the chain and you don't need to learn anything new is fundamentally really useful. But if on top of that you can layer on, and we're going to give you these extra powerful tools that allow you to use Rust, allow you to use C++, C, what have you, to write contracts, we can kind of slide in all this extra power without sort of rocking the boat of EVM being kind of the main point of adoption.
I would just drop the verses. So, you know, it's a very adversarial clause in there. You know, the verifier is one of the most crucial parts of our infrastructure. And, you know, we wouldn't have the interplay between the prover and the verifier if we didn't have Solidity, if we didn't have the EVM. So I would just say, you know, alternate VMs and the EVM.
Yeah, I would like to just reaction to like Harry like about like the EVM plus like things. I feel like it's like two different topics. One is like whether you want to use a different language or whether you want to use the EVM. But the EVM is a low-level thing, and then high-level like developers they're using the Solidity or they're using like some other language, but they all can compile to the EVM. So it doesn't necessarily you need to say like I need to able to support a different language. I need to swap like the EVM. Like you can just keep improving the EVM, like improving the efficiency and how to implement that to make it run more efficient and maybe like run like in parallel. But it doesn't mean necessarily you need to change that to support multiple different languages.
If you can create a compilation target for Rust that compiles to EVM and it's efficient, I will buy you a keg. Forget a beer.
Yeah, and then also on that like verification point, like the fact that it's implemented in Solidity is kind of a contingent feature. Right? You could have implemented it in something else. So I don't think like the EVM is really core to that. And yeah, I'd call it something like the future of VMs for blockchain, because I think in the future, especially as people can spin up their own rollups, maybe they could have like a app-specific circuit for their one application. Doesn't really, it's like a totally bespoke VM just for what they're doing. I think that's a more general like term to encompass like the future of applications we're going to see.
So like with the EVM, it always comes up with, you know, complaining about it is one of the most popular ways to use it. And so what do you see most VMs doing wrong right now? And what would you like to see change within like the next year?
Yeah, like, so for us, like we're building the zk EVM. That means like we're a lot heavy like to trying to putting the EVM into a zk circuits. So I think like So one thing like that, I think like for us, it's most like the EVM is not designed to be very zk friendly. So that means like for example, a lot of things will be designed using the catch hash function, which spends like a lot of cost to coding to be constrained inside the circuit. So I say like if we can improve the EVM to be like a little bit more zk friendly, and then like to be reduce the cost for the inside the zk circuit. So that means like eventually we can have the zk EVM maybe like in the layer 1, so that you can have you don't have everyone to re-execute that. You can just very quickly generate a proof so that every other validators can just easily verify that. But like in general, like maybe I think like an EVM, there's not like only EVM, there will be like a state account, that's like something like around the EVM. It's not like EVM opcodes, but like for all of a state account, they maybe like grow exponentially, and at some time you have like too much data to keep in the memory. That maybe like becomes potential issues like you need to solve before you come back to improve the EVM performance itself.
Yeah, really good point. And like to add on to that point about the EVM is not really designed to be implemented as like a zk rollup. Like similarly, like we use the Solana VM, certainly not implemented in such a way that it can be used very easily as an optimistic rollup. With like simple reasons like the state of the Solana VM is not stored as a Merkle tree. So and we're launching as an optimistic rollup, so that means we have to retroactively like stick this in. The way that I think about VMs are there's like how like quote unquote scalable is it, or how easily does it lend itself to being like implemented as an optimistic rollup or a zk rollup. There's also just like the usability, and then maybe a part of that is the compatibility with existing VMs, which is why I like what Arbitrum's doing. It's like you have EVM equivalents, plus you get to add in all this other stuff, which can like possibly enable new types of apps.
I think just to like call out kind of like one specific area, I think kind of cryptography is a really nice example of where like a lot of the interesting stuff you can do on Ethereum, you can do via Ethereum shipped with precompiles. And there's a lot of interesting math and a lot of interesting cryptography out there that would be really cool to use in smart contract systems, if not for the fact that implementing it in Solidity would be massively over expensive. And you would also have to implement this stuff in a whole new language. So the idea of being able to kind of take existing well-supported code bases, implementing kind of math and cryptography, and be able to kind of take those into the realm of smart contracts is just, really cool and something that we're not really going to get without sort of, in EVM world.
Yeah, just to play off that, the same thing that those precompiles really facilitate, and all of that cryptocurrency at the base layer in those precompiles, it's also slow. So like to get the Poseidon hash, which would help us a huge amount, it's just going to be slow. It's going to have to go through a lot of red tape, and then finally it's going to get to the EVM, and then we can kind of get to the layer 2 and innovate up there. So it's just it's a little slow.
So zk zk rollups doing like cool next gen testing on top of Arbitrum as L3s, taking advantage of the cryptographic tools Stylus can provide.
Will you buy me a keg?
See how it goes.
That actually builds really well into the next question of, do you think does compatibility or composability matter more? So if you have a VM, is it better that it can be composable and used with other VMs easily, or does it matter that it's compatible with existing code bases?
So I would say for example, for developers, it should be compatible. So that's it means you don't need to, it will be compatible with existing applications, it don't break a lot of existing applications. And that's what we take an approach to trying to be compatible. So to make the very developer friendly, and then they don't need to learn a new different language or a new compiling stacks. Maybe they have some more security concerns. But in terms of composability, I would say if in the future there's multiple layer 2 chains, it doesn't mean the VM to be I think the requirement for different VMs to be composable with each other, the requirement is lower than the compatibility the requirement. I think because you only need to, for example, verify other VMs, if other also have some zk version of that, you just only have some certain primitives to be able to verify the proof from the other chains to able to to do the bridging, the cross chain messaging. That would be enough for me.
Yeah, I guess in my opinion, the answer is definitely composability matters far more, given that compatibility it's like a go-to-market hack, like a growth hack. but it's not actually like a reason for that EVM to exist or a reason for it to be implemented as it is. This is something that we know very intimately, given we borrow the Solana VM, but that doesn't mean that like all the Solana projects will just instantly deploy to us. There should be some reason why, especially given like there's lower liquidity. So you have to add in those additional features so that apps can enable functionality that they wouldn't get otherwise. And if you look at like just the chains that try to just provide EVM equivalence or compatibility, like I don't know, like BSC when it first launched, was like one of the first EVM compatible or equivalent chains, and they got a bunch of forks of Ethereum projects. But like how many novel projects were really developed on that chain, and how much of a lasting narrative did that really carry?
So I think I agree that composability is most important, but like I think I would also say compatibility is pretty huge. I mean, in that like particularly in this, I mean, I think anybody here who is like developing any sort of project has hopefully dealt with or will deal with the kind of complexities of having your code audited. And being able to have code bases that like you can use in other places is really nice. Starting out on kind of a separate tool chain, there isn't kind of the overall like environment built up. There's a lot of value you can create, but it's certainly not easy.
Yeah, I don't think the EVM is the end of history. I think there's a lot of interesting things that can be done in the execution context. So at the end of the day, I don't think compatibility, obviously I'm going to say this, but compatibility is not that important. But leveraging the security guarantees of the base layer and the network effects of Ethereum as a base layer, that is what's important to us, at least. That's the huge priority is composability.
Yeah, and as far as like sharing tool chains and stuff, like for the Solana VM, for example, you share all the stuff that's written for Rust, and Rust is much older than Solidity, and it's probably much better audited in many ways.
So actually, to start this next question off then with Ben, on the subject of like EVM compatibility, do you think crypto will converge on a single VM? And if so, why would it not be the EVM?
So I don't. So I refute the second part of that. I don't have a scarcity mindset when it comes to crypto. I think that there's enough interesting things that can be done in the execution context that, if a developer wants to come and copy paste their code base to an EVM and a zkEVM, then that's great. They'll lessen the development overhead of their project. If they want to come in and write provable code, then maybe they want to come to Cairo and come to Starknet and build in our ecosystem. And there's going to be many, many more, in my opinion. So I think the future of VMs and execution context in crypto are going to be abundant.
I agree. No, I mean, I think that like I think it might end up looking like a power law. Like I don't think EVM is going anywhere probably as kind of like the default, but I think like that's one of the things about rollups that are incredibly cool, because kind of pre-rollups, if you wanted to experiment with a new execution design, you were making your own blockchain. You were worrying about like, okay, I need to like design, I need to make sure I have enough hash power for my proof of work. Whereas now you can experiment in the execution layer and do all sorts of cool, amazing things without kind of needing to worry about those other problems.
Yeah, agreed. I think that like definitely I don't think that there'd be like the same VM for everything. I don't know if it'll go as far as like app-specific VMs, but could see like an abundance of sector-specific VMs, especially for zk VMs in particular, where maybe like the zk circuit is optimized for some subset of features that's useful for some sector, and it's like not so efficient for another sector, but that's not what your VM is built for. So I expect to see more stuff like that.
Yeah, I also agree in general. So I would say if I interpret this question with another question, it's well, in the future there'll be only one chain I say probably not. There'll be definitely multiple chains exist in the future. So if there are multiple chains, then there definitely will be some diversity there in terms of VM models. But I'll say in general the EVM, it will be still a very large community, it has large developer base for using developing around the Ethereums. And then I also on the emphasize that I think EVM is also not a static status. It'll keep evolving, keep taking more like opinions and then some improvement proposals from the community, like keep improving, makes like be fixing some of the existing issues, and then making like a more and more like the efficient to run and execute, and then eventually maybe like a more zk friendly. I think that's all like the maybe like could happen in the future.
So it's like speaking about like different execution layer designs. Like, are there any execution layer designs you want to see in the future, and what trade-offs did you think about when designing your respective VMs?
I mean, I think Move is pretty interesting just because it's like very opinionated. So it's like it doesn't have compatibility or flexibility, but it allows you to like have a lot of kind of, controls in place at that level.
Yeah, like I would say like a different execution layer. Like I think like what's the most needed features of, because like it's like doesn't make sense for you to create a different VM like for just like some other purpose, like to create your own blockchain. I think there's a need, for example, like for higher throughput, like or to be more like easier to memory, like the efficient, or be able to do like some parallel executions. And those are features we'll be innovating like and then driving some of the new VM designs. I think like the FuelVM, I think, for example, it's a good example for designing a different things.
Yeah, I agree. Like Move, Sway, like other languages that are specifically designed, like DSLs for crypto, I think those are really interesting.
Although I'll also kind of like, I guess to like kind of argue against myself a little bit, like there's a lot you can do at the programming language level. So there's a lot that like you might not necessarily need kind of like the VM to do. And at least like in kind of modern computing, we have x86 and ARM, so there is some like differentiation, but it's certainly not as though there is kind of like a large number of different VMs. Now, there are some more that are virtual ones for programming languages, so there is like a variety, but it's certainly kind of there's certainly a lot of value in kind of consolidating into sort of a relatively smaller number of places, just because like each one needs kind of significant development resources.
Yeah, I agree. Like the language and the bytecode or the VM are pretty much decoupled. For our zk settlement, we end up compiling to RISC-V bytecode. We have to like change the memory accesses and stuff like that, but it's pretty much unrelated. There's a little work you have to do to get that working, but.
Yeah, that kind of architecture paradigm, I think, is what's going to be really interesting. Like, instead of taking Cairo as a provable execution layer and doing a prover verifier the entire zk circuit, compiling your Cairo code down to LLVM and just making sure that it's runnable. Those kind of things are really interesting.
Keeping with the entire.
Sorry, could I add on to that? Yeah, I think like trying to support multiple languages by like getting them all to compile down to LLVM, and the way that like zkSync did, where like Solidity, then they're like supporting Yule, and it like takes a long time for each one. I don't know if that's necessarily the right approach either.
But then you'll be able to run all of those on Stylus, since you can use the WASM backend to LLVM.
Yeah, I would say like another thing like designing a different VM is like to be pay attention like to the cost model. For example, like I think EVM like has a lot of iterations for optimizing that. Things like already stands test of time to being like not be DOS like attacked by them other like a malicious program to be executed on top of like the Ethereums. But like if you change like a different VM models, then the cost model, I think it's something like it takes time to iterate and to be more careful to how to avoid certain attacks.
My next question is a bit just, it's open to whoever wants to answer it, but it's, what role do you think rollups should play in pushing the EVM forward and as an experimentation ground for the EVM?
I mean, I have a lot of thoughts on this. Like, there's this fundamental like hard problem, which is that we would like to innovate, but also we would not like to break compatibility. Like, I think it is fundamentally like if Arbitrum adopts a feature and then Ethereum doesn't adopt it, if Ethereum adopts something that's not compatible with it and runs counter to it, you could be in a situation where there's a real divergence in tooling. That Solidity tooling for Ethereum doesn't support Arbitrum, which would be a mess. I do think there's like an interesting opening that like is kind of in front of us, which is basically L2s as a community kind of moving together to kind of create standards for ways that we can expand the EVM. Since if we're kind of all on the same page, we have a lot more power to kind of like help shape that direction than if we're sort of disconnected and kind of quabbling among ourselves.
Yeah, I would like to add to that is like so one thing we want to push in like for example to make sure that EVM to be more zk friendly, so that eventually I think that's also on the Ethereum's own roadmap to zk everything, like trying to say like, and then we as a layer 2 to build the zk EVM initially and put that in production, and then we can see what's the real cost, and then if there are any issues we can find like in the EVM, and how that can be helped like for the whole Ethereum community to pushing for like the end game, like the goal like for the Ethereum. To make sure like the EVM can be really put into the zk very efficiently. And then another thing I think will be improving like the very interesting for the EVM is what kind of a new precompiles that we can add to the EVM to enable like more applications to be developed on top of the Ethereums.
Yeah, as far as like rollups getting together and like pushing their own EVM standards, I feel like that would hit the same headwinds that like just changing the EVM on Ethereum would hit. So I don't know if that would be the right ground for it, but I think that rollups as a service like Eclipse are the right breeding ground to really experiment with the EVM, because it's just your own one rollup. You're not impacting anyone else. Like, whereas on Arbitrum, it's like everyone's still living there together to share that space and share the VM.
As a completely different VM out of the box, I think there's not really an expectation for us to push any of the EVM stuff. But I think what's been interesting in our ecosystem is that we have tooling like transpilation. The warp transpiler is EVM, is Solidity to Cairo transpiler. Even as reference software for other chains that are non-EVM compatible, that's interesting. We have Kakarot, which is the zk EVM interpreter that's running on Starknet L2. So these kind of like emergent EVM, just because EVM has so many developers behind it, you can't get away from it at some point. You see these things come out, which are really cool.
Oh, just one small thing to add, which is more just you reminded me of an idea that I really like that would just be really cool, which is that one of the things that rollups could let you do is to kind of have basically sort of test nets with real value running on top of mainnet. So there's a really nice idea, which is basically like for a given kind of like new EVM feature, just having a kind of like 6-month-long test net that is like real value, really secured by Ethereum, but not intended for the long term could be very cool.
Yeah, Canary chains, kind of like Kusama and Polkadot. I was talking to I think it was like some fund that owned like a ton of Gnosis chain. They kind of view Gnosis chain as acting. It's not a roll-up, it's a full layer 1. But I agree, it should probably be a roll-up. And actually, Gnosis chain probably shouldn't even serve that role. But there should be some roll-up that serves that role.
All right, so actually, like to build on top of the warp transpiler, languages traditionally have been closely associated with each VM. How do you hope to see languages diverge from each EVM individually? And do you think languages should be back-end agnostic or be closely tied to the VM to take full advantage of the VM?
I would say I think language, doesn't need to be bound to a certain VM, although it takes some assumption of a certain VM opcodes. And then, for example, the way the Solidity allows you to embed some assembly code to that. But I think in general, that should be a compiler problem. Try to see how to compile a language to a different VM models. But I feel like the language is still quite powerful tools, because developers are already developing a lot of tools and then a lot of existing applications on top of certain language. So I think a language should be it's hard to change the language features, but it can be maybe compiled to a different VM models. And then for people who want to push for a very gas efficient programs, they will probably to do the go beyond some levels. I think that's not for the more regular developers, and they want to someone just directly writing the EVM codes to achieve the best gas efficiency. And then for this person, probably they can just directly using the opcodes provided from the lower level of VM.
Yeah, I agree. I think the VM acts as more of a constraint on the types of languages that can be supported, because there might just be some operations that there's no succinct or efficient representation.
Yeah, it's a hard problem because, especially in the zk space, we need a VM that operates efficiently within Starks and over a finite field. You're not going to get any of these things out of the box from a general purpose programming language typically.
So I don't think this is the case anymore, if I remember correctly, but for many, many, many years, Solidity had an error that if you were developing, you could run into, where it refused to compile and it said stack too deep, because the code of the Solidity compiler was so intertwined with the fact that the EVM only lets you read 16 items back on its stack, that this surfaced kind of very directly in the compiler. So I say that mainly to make the point that I think like for EVM-based languages certainly, and I think because of gas efficiency, there has been like a strong tie-in with the EVM.
So like to continue on like the thread of like applications tying in with the VM, when you guys have been designing or working with your VMs, have you thought about the programs that your VM design will enable? And are there any new types of programs that you're looking to enable with your VM design?
Yeah, so we're more constrained by the way that we think about like what's the right PMF for app-specific rollups. Just like what are good applications for chains that have lesser composability than all living together on Arbitrum. They have high throughput needs ideally, so maybe it could be like a game or something. And ideally, they require their own custom opcodes or system programs like what we're describing. So we think a lot about gaming and physical infrastructure networks, not really because of like the underlying VM, but because of just the fact that this is a dedicated rollup for an application.
Yeah, definitely on our end. I mean, I think pretty general overall, though. I mentioned earlier, I think like cryptography is probably going to be like the first big application just because instantly it's going to unlock so much.
Yeah, but it's like I think we didn't like design really things like a VM, like we're just trying to inherit of the EVM. So like probably like I'll just leave the answer.
We see some things come out of interesting properties of zk, of like of Cairo VM and zk is like recursion. So recursion lets us prove a Cairo program ran correctly, and then we can in parallel run those proofs and then check that proof again. So a recursive proof generation of a recursive proof generation. And the emergent thing that comes out of that is we can do these layer 3s. So you can, instead of having the layer 2 write its state transition and prove its state transition to L1, we can also have that as an application-specific layer at layer 3. So that gives rise to privacy at layer 3, to higher throughput at layer 3, to configurable nature of layer 3 for app-specific stuff. You see these things kind of emerge out of the Cairo VM and proof recursion.
Yeah, I would just like add one point. I think like a lot of features can be just done like in the like smart contract level. Like it doesn't necessarily to be change the VM models. Although like sometimes like if we change the VM, like making for example the zk proof like more efficient, that might be like things like would be interesting to think about. But like I think we're trying to see like being compatible. Like it's very powerful things.
Yeah, are there like constraints on these L3s given like maybe the proof system is not able to support certain types of operations, or what does that end up looking like?
Well, once we have the recursive proof generation, so right now the Cairo verifier or the Solidity verifier that verifies the execution of the Starknet L2 is written in Solidity. But now that we have a Cairo version of it, that removes the bottleneck for the layer 3s. So limit is still just like steps, the amount of steps the VM has to take. It's not unlimited, it's not unbounded, but we've at least unlocked the ability to do it.
Another question here. Do you guys have any predictions for the future of VMs 1 year from now? And where do you think everything will sit?
I would say like the 1 year from now, like the EVM is probably like still stay like quite similar to what we have. Like I think EVM is kind of like a foundation of the whole Ethereum. Like that it doesn't change a lot. Like there's some like opcode change, for example, like they probably like deprecate the self-destruct, which is like not very useful things. And also, and then there's definitely things like the new opcodes may be introduced like to enable some applications to read directly some random number like we see like a random like as new opcode to replicate the difficulty, which doesn't make sense with the POS chains. I say like relatively will be quite stable for the EVM, not a lot of changes, but there'll be like some minor improvements to further like make the developers like more powerful to build like more innovate on the applications.
Yeah, I'd expect like 100+ new VMs to launch, like new corresponding rollups, many of which are forks of the EVM or SVM or other well-known VMs to support like different kinds of functionality.
Yeah, I definitely think that EVM has a lot of staying power, and I don't really expect to see that change anytime super soon. Like I think there's a lot of complementary work which is really exciting and that will be kind of like flourishing around it. But yeah, definitely EVM.
I'm notoriously bad at predictions.
All right, so as a bit of a closing question here, how do you hope to see your VM used in the future, and where do you hope to see it go?
Yeah, we hope to see like the zk EVM like become like the very powerful tools to scale like the ETHs like the to with secure and then like the very like the cheap transactions on the layer 2s, and then like the so since we're stick with the EVM, we're trying to power lots of like ETHM developers to develop on top of us.
Yeah, so we recently announced Polygon SVM, which is an SVM chain for Polygon using Eclipse under the hood. So want to announce we have a handful of other SVM rollups spinning up for other layer 1s. So going to be announcing those over the next month or so, or over the next couple months. And so that's one category, but also want to see much more next generation crypto games. So folks doing more than just putting some NFTs on chain, but doing very crypto native game mechanics, such as streaming micropayments or something more sophisticated than that.
I think the biggest hope with Stylus is definitely that it kind of opens up the ability to develop smart contracts to kind of a massive degree of developers that can't right now. It's kind of funny, it's not like Rust is a language that has a lot of programmers. It's still a pretty small language, but it's still a massively larger number than use Solidity. And I think just kind of widening the tent of kind of who can write smart contracts is the really big hope.
The Cairo framework, it's cool because it lets you prove arbitrary logic given any input. And so that framework is in production today, and it's underpinning StarkX systems. If you use DYDX, immutable, so rare, it's facilitated hundreds of billions of dollars of cumulative volume. And now we have StarkNet, and StarkNet is optimizing for general computation. All these things underpinned by Cairo. So really, what we want to see is just more usage of these projects, more usage of the Cairo VM.
We ran kind of fast, but I don't know if they did.
Thanks.
Thank you.
Thank you.